Hi guys, this is Tony from Eliezer and we are going to continue from where we stopped in the tutorial Indices 1. I highly recommend all those who have just joined us to make themselves conversant with the content in the tutorial Indices 1 before they can proceed to watch this one. In tutorial Indices 1 we learned about indices with positive integral powers. In this tutorial we are going to learn about indices with positive or negative fractional powers together with indices with negative integral powers. But before we proceed to do so, an important assumption has to be made. We are going to assume that the fundamental law of indices, the one that deals with multiplication of indices, is true for positive and negative fractional powers. It is also to be further assumed that this law is true for negative integral powers. So let us look at the meaning of a to the power p over q and a to the power 1 over q, where a, p and q are positive integers. To do this, consider 4 to the power a half times 4 to the power a half. This will be equal to, assuming the fundamental law of indices holds for fractional powers, 4 to the power a half plus a half, and a half plus a half is equal to 1. So we shall be having 4 to the power 1. And 4 to the power 1 is 4 itself, simply because there is just one 4. In 4 to the power 2 there are two 4's, that is why we say 4 to the power 2 is 4 times 4, but in 4 to the power 1 there is just one 4, so that 4 becomes the answer. In general, any number to the power 1 is that number itself. So on simplifying we shall have 4. When two similar numbers 8 and another 8 are multiplied to get 64, we say that 8 is the square root of 64. Now in the same way, two similar numbers 4 to the power a half and another 4 to the power a half have been multiplied to get 4, so we shall say that 4 to the power a half is the square root of 4. Now consider 8 to the power a third times 8 to the power a third times 8 to the power a third. This will be equal to, assuming once again that the fundamental law of indices is true for fractional powers, 8 to the power a third plus a third plus a third, and this shall be equal to adding the ones in the numerator since the denominator is the same, 8 to the power 3 over 3, and this will further simplify to 8 to the power 1, and any number to the power 1 is that number itself, so we shall have 8. When three similar numbers 4, another 4 and another 4 are multiplied together to get 64, we say that 4 is the cube root of 64. So in a similar way, three similar numbers 8 to the power a third, another 8 to the power a third, and another 8 to the power a third have been multiplied to get 8, so we say that 8 to the power a third is the cube root of 8. It is not difficult to show, following the same line of argument, that 16 to the power a fourth is equal to the fourth root of 16. In general, 8 to the power 1 over q is equal to the kth root of a. It is not wrong to claim that 4 to the power a half is the 2th root of 4, but mathematicians prefer not to say it this way. They say 4 to the power a half is the square root of 4, but it should still be noted that square has something to do with 2. Now let us try to understand what a to the power p over q means. A to the power p over q is equal to a to the power 1 over q times p, which is equal to, from the third law of indices, the one that deals with multiplication of powers, a to the power 1 over q, the whole expression to the power p, and simplifying what is in brackets first, this will simplify to the kth root of a to the power p. Once again, a to the power p over q is equal to a to the power p times 1 over q, which is equal to, from the third law of indices, the one that deals with multiplication of powers, a to the power p, the whole expression to the power 1 over q, and this will simplify to the kth root of a to the power p. And notice that the power p can be inside the root sign or outside the root sign. Next, let us learn about principal roots. By definition, the principal roots are the positive even roots of numbers. By even roots I mean square root, fourth root, sixth root, and so on and so forth. Consider the equation. X squared is equal to 4. Of course, x can be equal to 2 or negative 2, but in brief we say x is equal to plus or minus 2. In other words, there are two similar numbers 2 and negative 2 that seem to be the square roots of 4. Now the question is, which of these two numbers corresponds to 4 to the power a half? Should 4 to the power a half be equal to one of them or both of them? To answer this question, consider 4 to the power a half times 4 to the power a half. This will be equal to 4 to the power a half plus a half, which is equal to 4 to the power 1, and any number to the power 1 is that number itself, so we shall have 4 as the answer. Let this 4 to the power a half be 2 times, and let this 4 to the power a half be -2, so we shall have on multiplication -4, and since these two answers are not the same, clearly this is a contradiction. But if we had equated the first 4 to the power a half to +2 and the second 4 to the power a half to +2, then on multiplication we would have got +4 and there would not have been any contradiction. Or if we had equated the first 4 to the power a half to -2 and the second 4 to the power a half to -2, then on multiplication we would have got +4 and there would not have been any contradiction. So, 4 to the power a half cannot be both +2 and -2. We have to decide one of these. Now mathematicians have decided that 4 to the power a half, which is equal to the square root of 4, is equal to +2, and +2 in this case is called the principal square root to differentiate it from -2. Similarly, root 9 is equal to +3, not -3, and 9 to the power a half is equal to +3 and not -3. And, again, let us consider the equation. X to the power 4 is equal to 16. X will be equal to 2, or -2, but 16 to the power 1 over 4 is equal to 2, and not -2, so the fourth root of 16 is equal to +2 and not -2. +2 in this case is called the principal fourth root of 16 to differentiate it from -2. Now we know that the eighth root of p is the same as p to the power 1 over a, but when a is even, the positive eighth root is considered to be the answer. Next, let us look at the meaning of a to the power 0, where a is any number apart from 0. From the fundamental law of indices, a to the power m times a to the power n is equal to a to the power m plus n. Now supposing m is equal to 0 and n is any other number, then on substituting for m with 0 we get a to the power 0 times a to the power n is equal to a to the power 0 plus n, which is equal to a to the power n. So rewriting the above equation, we shall be having dividing by a to the power n on both sides of the equation, we shall get, and a to the power n divided by a to the power n is equal to 1. So any number to the power 0 is 1, but 0 to the power 0 cannot be 1. The reason why 0 to the power 0 cannot be 1 will be discussed in the following explanation. Consider 5 to the power 3, divide by 5 to the power 3. This will be equal to, from the second law of indices, the law of division, 5 to the power 3 minus 3, which is equal to 5 to the power 0, and like we have just learnt, this is equal to 1. Another way of working out 5 to the power 3 divided by 5 to the power 3 would be writing it as. Now the 3 5's in the numerator will cancel with 3 5's in the denominator, leaving 1 as the answer. But we know that if the 5's were zeros we would not have cancelled, for we cannot divide by 0, and hence we would not have been able to get 1 as the answer. And this is the sole reason why I said a cannot be equal to 0. Next, let us look at the meaning of a to the power -n, where a is any number apart from 0. Consider a to the power -n times a to the power n. This will equal to a to the power -n plus n, and this follows from the fundamental law of indices. So on further simplification we shall have a to the power 0, and provided that a is not 0, any number to the power 0 is 1. So we shall have 1 as the answer. So rewriting the above equation, we shall have dividing by a to the power n on both sides of the equation, a to the power -n will be equal to 1 over a to the power n. Below is a summary of all the important facts we have covered about indices. Now guys, we have come to the end of this tutorial. If you have found this tutorial useful to you, then you can subscribe to my channel for more video tutorials. Otherwise, I thank you for keeping up with me up to this far. Hope to catch up with you guys in my next tutorial, Indices 3, where we shall be discussing solutions to various questions about indices. Once again, I am Tony from Eliezer Online School, and I wish you the very best of your day.